The code looks obvious, the branch looks correct, and yet the value is wrong later. Not because the logic is wrong, but because your mental model of control flow is. Branches feel like decisions that echo forward. They don't. The CPU forgets the branch immediately. Only state survives. Once you see this, entire bug categories collapse. A branch is not a fork that carries meaning forward. It's a momentary routing decision. Once execution exits the structure, the path is gone. No memory, no history, no we came from the else. Only values remain. If you trace paths past the branch, you are inventing information that the runtime does not have. Here's the silent assumption. Later code still knows why axis is 10. It doesn't. By the time audit axis runs, isAdmin is irrelevant. The branch no longer exists. Only axis remains. If a later bug occurs, developers instinctively recheck the condition. But the condition already did its job and died. The bug isn't which path ran. Debugging the condition here is wasted motion. Humans think in stories. Programs don't. You remember, we went through the admin path. The CPU remembers. This integer equals 10. That mismatch creates phantom logic in your head. Logic that doesn't exist at runtime. That's why these bugs feel random. You're debugging a story. The machine is executing memory. This is the exact point where mental models diverge from reality. This code looks harmless. But notice something critical. Only one path assigns score. If pass is false, nothing changes. But execution still continues. Developers often assume if the if doesn't run, nothing happens. Wrong. Something always happens. Execution advances, state persists, previous values remain active. This bug doesn't live in the if. It lives in the absence of assignment. The CPU doesn't infer meaning. It doesn't think score was supposed to be updated. It only checks, did an instruction write a new value? That's why missing assignments create bugs that feel unfair. Because nothing looks wrong. No crash, no error. Just a value you didn't expect. Surviving quietly. And it's not just defaults. It's stale values, old state, previous outcomes, anything you didn't overwrite. It stays alive. So when you debug, don't ask what the code intended to do. Ask what the code actually wrote and what it never touched. Flags are where this problem explodes. The bug isn't the flag. It's that flag merged time and state. The second if doesn't know when ready was set, why it was set, which path caused it. It only knows the current value. If execution order changes, or a condition runs earlier than expected, the flag lies. Perfectly legally. This is why flag-based coding feels haunted. Nothing is technically wrong. The mental model is. Here's a classic late-stage bug. Each branch makes sense alone. Together, they fight silently. There is no primary path. There is only last write wins, If both conditions are true, the second assignment overwrites the first. Developers read this vertically. The CPU executes it temporally. The bug doesn't announce itself. It just waits. Here's a method you should adopt. State forward tracing. Step 1. Mark every write. Any line that assigns, mutates, flips a value, updates a field. That's a state event. Step 2. Ignore the story your brain wants to tell about which path really happened. Step 3. At every branch exit, you ask, what values exist right now? Not why, not how, just what. And step 4. When a bug appears later, treat it as a survival problem. A bad value survived? A missing write let an old value live? Or a later write overrode a correct value? That framing makes behavior predictable. Early returns work because they eliminate futures. They don't preserve state. They prevent it from existing. This is why they feel clean. They reduce the number of states that can survive. Less future, less state, fewer bugs. This is not style. This is execution control. This is the most common objection. I know which path runs. Sure, today. But your confidence is tied to the current shape of the code. Refactors change order. Someone extracts a function. A condition moves. A call happens earlier. And suddenly, your I know becomes a bug report. The CPU never had that certainty. It never cared about your reasoning. It only executes whatever state exists at the moment a line runs. So if correctness depends on remembering which path ran, the design is brittle. State-based reasoning survives change. Path-based reasoning breaks the moment the code evolves. Once this clicks, you start designing differently. You stop letting values float through the program, hoping they'll be correct. You make assignments explicit. You reduce shared mutatable state. You collapse outcomes so fewer states can survive past a decision. This isn't about writing clean code. It's about reducing the number of possible worlds your program can be in. Because every extra surviving state is a future bug you have to debug later. And the CPU won't help you by remembering how it got there. Design becomes memory control. What is allowed to live? What must be overwritten? And what futures should be eliminated entirely? If you remember one thing, remember this. The CPU forgets decisions immediately. It keeps values. Branches are questions. Assignments are answers. After the question is asked, it disappears. The answer is what continues through the rest of the program. So when something breaks later, don't hunt the question first, hunt the surviving answer. What value exists right now? What line wrote it? What line didn't? What later replaced it? That's how you debug like runtime. And stop being surprised by behavior.